Howdy. It's Fault Snake here. Didn't think I'd be making another video, but this is less about draft and more about a tool that I ended up making between some work things that I thought that people might like. So here we are. I'm very good at this. So I'm not trying to make this a big thing, so making very minimal slides here, but this is effectively a project I did that is a genetic algorithm to draft team optimization. And as I was making this, I kind of realized it was like, you can, if you really want to, generate caves from scratch. So that's a thing we do. We'll talk about how this works and all that here in a moment. The first and foremost is that this is not a bot, so I haven't used this yet for my own belts. I had considered using it to optimize some EVs, which I didn't even end up having it done by them. Maybe I'll use it, maybe I won't, but at the end of the day, it's not a bot. It's not a tool that plays the game for you. It does use some bots to do optimization, and as you'll see, but the final output is actually just a PokePaste style team that you'll throw into Showdown and pilot yourself. So it's not playing for you. Just like to make that clear. So what's the problem that we're trying to solve? Just trying to make it very explicit, is that if you were trying to solve this not like an experienced veteran draft player or even Pokemon player in general, this can be pretty daunting, right? If you're trying to optimize your Pokemon team per EVs and moves and natures and items, there's a lot of decisions that could happen. And so the actual search space is pretty big. You would think that for draft, the search space isn't so big, but it's still markedly big. And unlike in general play on the ladder, where you tend to pick, there's broad metagame considerations to have. Ultimately, you tend to pick a style of team that is broadly good. This is much more precise. And so if you were really to really go through the stuff, you might take hundreds of hours trying to optimize it. Of course, no one has that for draft. I hope not. And you have to counter different strategies too. So the broad solution here is coupling the Pokemon Showdown Battle Simulator with a genetic algorithm. And I'm not going to get too much into how this works, but to me, this is one of the earlier forms of machine learning that I ever implemented. I used it in a very scientific setting, and it's kind of neat to be able to use it in a Pokemon setting. The idea is that you're going to treat teams kind of like genomes, right? So the whole idea of a genetic algorithm is to borrow kind of how natural selection and evolution works in the real world and apply it in an informatics space. So you'll treat each team as a genome that evolves over different generations. And the degree to which a particular team or genome gets to reproduce and survive is dependent on its fitness. And that fitness will be, is a measure of how it does in actual Pokemon Showdown battles. Of course, we're doing this all locally. I'm not playing other humans. I'm not a big fan of bots on the ladder. And this can actually help us discover strategies that humans might miss, if that's your kind of thing. And the broad workflow is just this. He'll generate a random population of teams. You'll see that it's not as random, or it doesn't have to be as random. You'll battle opponent teams, and then you'll select what are called the elite teams, the elite performers, the best performers. And some of them will get carried forward completely as is, but you'll also mutate these and even breed them with each other at the time. So maybe one of your teams had Savali and the other one didn't. One of the new genomes in your population might be just the same teams, but they traded Savali and Togedemaru between each other for that team. And just do this over and over again. And you're keeping the best performers based off of fitness functions. So ideally, the team gets better through time. The broad system architecture here is a Python-based genomic algorithm, and it's interfacing with Showdown via the Poke in the library, and that's also what carries the heuristic AI that's being used. And since CSV database is right now specifically for Gen 7, but there's no reason you can't use any other database. And most of the optimization is actually found in the config files, so you can see this little screenshot of my Lytics page here that the EV has some presets, but this GA config is there, and then also you can talk about your team and your opponent's team, their draft. And I'll show you some of that in a demo later. The broad flow is that the program reads the config files, instantiates the engine, connects to the server, does a bunch of battles, does the fitness calculation, and then evolves. And this repeats until either you've reached the predetermined number of generations that the code is set to run, or you stop it because you're happy enough with how things are going. You'll get these sort of optimized checkpoints sometimes. One of the nice features is that if this stops, you can resume it at every 10 generations, and also pull the teams at every 10 generations. So that's kind of neat. And the idea is that you'll update these teams. I can also see how the evolution have no time. So the fitness function is kind of the main thing here. Originally, the only function that I had for fitness was just the win rate. But thinking about it, it didn't make a lot of sense. Like, pardon the squeaking. It didn't make a lot of sense because if you win by 1, it could, 1 mon left or even 0 mons left. That could have been the result of chance, a bad roll, a crit, something like that, right? So by incorporating differential, you can sort of enforce a little bit more consistency, right? And then if you increase the differential even more, right, you start to favor strategies that can 6-0 people, so you'll probably convert your team all the way to set up sweepers and stuff. But at a modest value, it ensures that your team doesn't just eke by and is subject to variability, but instead can kind of convincingly win at least 2-0, for instance. And then I also added later the synergy. So this was the most recent addition to the algorithm. And the idea is, like, if you care a little bit about the fundamentals of Pokemon, that's where this will take advantage of it. The idea is that do you have good type coverage? Is there defensive synergy, and do you have good speed tiers? These are sort of fundamentals, and you can weigh those in here too. All of these values are, of course, adjustable in a config file. So these sorts of advanced features of the algorithm is stagnation detection. Whenever your change in the fitness function doesn't change after 5 or more generations, the mutation, the rate at which you're messing and tinkering with the teams, will increase. This idea being trying to get you out of local optima. Likewise, every so often, that is, as it's configured every 10 generations, you will go back and look to the past generations and reintroduce some of the best players from a decade ago, 10 generations ago, as it were. And this idea of reintroducing old members into the current generation, you can recombine old Pokemon with, or rather old teams with new teams, and that can make it even better teams, that sort of thing. Yeah, the recombination just means that maybe you've discovered a core in one team, and then multiple good Pokemon in a second team in this population. This will allow them to mix and maybe advance even further. And this last, well, I have more advanced features, but the last for this slide is I also added the ability to have must-bring Pokemon and required moves. So, for instance, if only some of your Pokemon can use Z moves, that sorts of thing. But also, we'll talk about that in a minute. some more advanced features. The Sorp's Energy, which sort of covers those Pokemon fundamentals. I don't want to get too much into this. I don't know what good values are for all these. I do think that the speed cure distribution can be reduced a little bit, but that's still pretty good. I didn't talk about the diversity metric at all here. So something I didn't write down, but that does exist, is a penalty against teams that are not diverse, rather populations that are not diverse. So look, all I'll do is if you include that in your simulation, it will make sure that you have not just one strategy represented in your population of good teams, but it will push the teams to be more and more diverse and be more sorts of archetypes. The diversity being the different Pokemon, the different moves, that sort of something. I didn't write that here, but it does do that too. So we'll just walk through a couple of use cases. This use case 1 is the one that I actually began to write this for. And the idea is that if you have a lock-in team, right, you have your 6 months that you want to bring, you can actually optimize BEV spreads, right? This is a very common thing to do for teams in general, where you can speed creep, or you can not invest more speed EVs than you need to, that sort of thing. And maybe, for instance, you have, in this case, all your Pokemon are set, but each of your Pokemon have one move slot that could be one of 2 or 3 things. This program supports you being able to do that and solve that problem, which is really cool. And you can parameterize the configuration to really solve this problem easily. And it will be very, very quick. And so you might discover that some Pokemon might need 236 speed, tap speed, timid, tapu lately, or maybe avoiding 2-hit KOs from Life Orb or Ninja by the specific HP investment. So this is kind of cool. You might have some final calls here. There is, of course, this much wilder use case, which is you can just have your complete draft and your opponent's complete draft, and you can run the simulation for a long time and with high diversity to explore options and generate a lot of teams. And by the end of it, you should have a couple of high-performing teams that maybe use different strategies, and you can kind of pick from those. And I think that this is interesting. It will take a long time to run. Even in my testing, which isn't super verbose, but I have not yet run it far enough to really feel like this has given me an incredible team, but it does find cool and interesting stuff. I ran it earlier and it found that Hypnosis Bronzong was just so good, and I think that's fiendish, frankly. So this is really cool, but I know I'm not such a big fan of this. It kind of feels like taking the fun out of draft a little bit, but I could see people using it and enjoy using teams generated from here. But the last use case is probably my favorite, which is more about building around key Pokemon, right? So in this scenario, you love, say, Choice Band Togedemaru, and you really want to build around it, right? You have a featured Mon, and rather than pulling the agency move of sacking it turn 1, you want to actually make it put in work. So in this case, you can set the particular Pokemon to be must bring. You can even set its moveset if you want, its item, its nature, and its EVs. These are all things you can lock in. And then you can just allow the other 5 Pokemon selects to be completely flexible. And what this will do is find good strategies that support your featured Mon, in this case, Togedemaru. It'll find partners to counter weaknesses, that sort of thing. So you could imagine finding a ground immunity that gets brought a lot, or even a strategy of team that just appreciates the U-turn chip from Togedemaru. So quite good. I like it. It's an interesting way to build a team around a featured Mon. And if I use this tool, it will probably be for something like this rather than the other case. To figure out broadly, even if I don't use the exact game that comes out of it, broadly, what does it seem to feel like in order for this to put in work? So it's not a perfect or even particularly good product, but it's neat and it's fun, and I'll show it in that moment. But some future improvements. Right now, the decision-making AI I'm using is one of the heuristics built into PokeENV, and both sides use it. So it's a little bit of you could definitely do better than that bot, that AI that's piloting the teams, and that would definitely give you better results. There's also a genetic algorithm concept called islands, where you can kind of have different islands of different populations evolving in tandem independently, and then every so often you mix those populations up and see what happens. You could use a more data-informed strategy to figure out the percentage of the moves that are being included on Pokemon. For instance, if U-turn is on 80% of sets, you could say that there's an 80% chance that you draw U-turn. That might help. I don't know for sure, but it might. There's also an adversarial strategy where you could imagine running the genetic algorithm from your opponent's perspective, and then plugging the output seam back into your perspective, and then back and forth to really hone and counter team the counter team, as it were. And then there's a sort of technical idea of, right now I'm flattening all the different optimization criteria into a single value. But in principle and in practice, you could do multi-objective optimization and find the Pareto firm. So that would also be much better. So with this, I'm going to go into a little bit of a demo. I might do a video later on visualizing how the evolution works through time, but I'm not going to do that today. So I'm going to snip together the demo. All right, so here we are in my terminal. This is more or less version 5 of the code. So here we are here. You can see I've already run this before. So you can see all these checkpoints. The JSON checkpoints allow you to resume where the program left off in case something happens. Simply tail. Now you would temp.json. You can see that it's keeping track of what it needs to do to run things. So let's just clear that. So to run this program, you have to have a local instance of Pokemon Showdown going. You can see I have one here. I used a setup Showdown script to do so. It's running elsewhere, and you'll be able to see it in a second. But the main thing you need is actually just the stuff in the config. I guess I can tell you the Python requirements. It's all in Python, of course. So that's the requirements. It's actually a relatively minimal build. You can use Conda and stuff if you're so inclined. And then you need what's in the config file. So you look at config. You can see these different files. The Pokemon data and the move data are just databases. But you can look at the EV presets, and you can see that there are sort of built-in presets that you can specify here, and you can define your own. So if you really think that your opponent is going to bring a set, you can actually define your own set and add it to this, and then you'll be able to add it to their game. So again, let's clear this out. Cat config my keen. So this is what your keen files will look like. You and your opponent's team will look more or less the same. So here is the draft here. So you can see, for instance, Toydamaru, and you can set a set of moves that it plausibly can use. So if you really wanted to, it could be every move Toydamaru could use, or in this case, you can constrain it to a set of somewhat likely moves, a set of somewhat likely items, including Z moves. So if you have Z captains, this is how you can encode the Z moves, abilities, natures, and preset EVs. It will learn, for your team at least, not for your opponent's team, but for your team, it will learn other EV spreads. So this EV preset's just kind of where it's starting, but it will change from there for sure, and it'll optimize. Yeah, so here's what it looks like. Are there any of these that have must bring sets? Yeah. For instance, Mule is set as must bring here, and it has the required move of Stealth Rock. So one of its move slots is reserved for Stealth Rock, and you will always bring Mule in this instance, no matter what. So would that be good? Would that be bad? It doesn't really matter. But this is kind of where it starts. Yes, okay. So that's what your Keem files look like. Let's clear this again. I suppose we can look at the opponent's team real quick. But it's going to be pretty much the same. So again, if you really were so interested, you could set these to be, you should swap their positions and then see what the best build into your team is, and then try to build against that. So that's another cool use of that. All right. The last big thing in the config folder is, we're gonna go banana proper. Let's get config is actually the settings for the program and its behavior. So there's a lot of different things that I can do here. You can edit them all here. So the population size, how many survive is the elite size, how many generations, the number of battles and battles per opponent, the mutation rates, the weights of the fitness function, the probability of your opponent using a preset versus a random spread. The random spreads can be good to simulate a sort of your opponent doing something wacky or optimizing in a way you didn't expect. Mutation chances, where these files will live. Whenever you stagnate, in this case after 5 generations of the fitness changing, you'll increase the mutation rate. This is the elite luck back, some Keem synergy. I'm still not sure what are great values for all of this. I do think the synergy weight might be better off lower than higher, but I don't know. And then diversity and adaptive pedal counts. So as the program was on, you can speed it up by running fewer battles because we're fighting. So that's pretty cool. We'll clear this one more time. And now we should just run it, and then that'll be that. So in this case, it's going to be Python Wizard v5 updated. Just uses the full database instead of my test database, so that's why it's called that. And then if I hit enter, it begins. Again, I have a showdown tab open, and I'll let this run for a minute before I move over to that, so you can see what it looks like at the end of the generation. At the very beginning, he'll be bad. Almost there. So you can see the fitness score, not very great. Differential's not great. Barely winning about like 1 flip. But over time it'll grow. So I'll go ahead and show you. I need to reconnect. Okay. You can see in my look instance of Showdown, all of these games being played, and if you can click on one, maybe we can click on one, and you can see what happened. And you watch 3 back. Okay. So in that intervening period, there's been about 30. Easy, the fitness function is already increasing. Before it should get up to 70 relatively quickly. And if that's a relatively expected result. I've now pause this for a sec. Alright, we're back here. And that's because I paused it, just because I want it to keep running, and it causes a lot of problems when you do that, so I just brought it back out. You can check the evolution log, which will have been overwritten from my last though, but that's okay. So I got as far as the 3rd generation. And yeah, you can see the sets that it was outputting this early on. So in generation 3, it keeps the top 3 and reports them here, just to have a sense of what's happening. In this case, the best team seems to be a Life Orb, Mew, a Band Swampert, Colberberry Gourgeist. Yeah, this seemed to be the way to go, but of course it would not necessarily. This is very early, so this is not a particularly good team. The differential is only less than 1, and it can get quite high. But that's it for now. I guess I can show you. Yes. Let's fill it in. I've took a coin. 1050 for my last run. Or you can see that the stat spread, for instance, for this Mew is a lot more optimized. It seems like a sort of mixture between a support and a setup Mew. It has Focus Sash, but it has 116 HP. It does max speed. I wonder if there's a more nuanced. Yeah, like this Tentacruel having 248 speed creeping something, or likewise Heracross 244 speed, realizing it doesn't use it all for those matchups. So there we go.